All right, this is section 4-6. We're going to take a look at congruence in right triangles. All right, so some vocabulary. So, segments that are congruent have the same length. Well, that is true. Polygons that are congruent have the same shape but not always the same size. That's false. Incongruent figures, corresponding angles have the same measure. That is true. All right, what is the hypotenuse? So a hypotenuse is a leg of a triangle, but more specifically, the hypotenuse is the side opposite the right angle in a right triangle. The hypotenuse is the longest side in a right triangle. Okay, so let's use our vocabulary here. We're going to underline the correct word to complete each sentence. So one side of a right triangle is a hypotenuse. A right triangle has two legs. The length of the hypotenuse is always greater than the lengths of any of the sides. All right, so let's cross out the side that is not a hypotenuse. Of the choices here, segment BC is not a hypotenuse. Circle the legs. AC is a leg, HI is a leg, and ED is a leg. Okay. All right, so to continue with our congruent triangles, we can also prove triangles are congruent by, if I have a right triangle and I know a hypotenuse and a leg are congruent. So here's theorem 4-6. If I know the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then I know the triangles are congruent. So here it is in pictures. I'm giving two triangles. They're right triangles, and I know two legs and two hypotenuses are congruent. Therefore, these triangles must be congruent. So to use the HL theorem, the triangles must meet three conditions. Complete each sentence with right or congruent. So the first thing I need to know is that there are two right triangles. Can't use HL in a non-right triangle. The triangles must have congruent hypotenuses. And they must have one pair of congruent legs. Okay. So how do triangles in a take note meet the first condition in exercise 9? Well, the triangles for both PQR and triangle XYZ are right angles. Okay. How do the angles in the take note meet the second condition? Okay. The HY hypotenuses PR and XZ are marked congruent on the diagram. And then how do I know the third condition are met? So the legs, PQ and XY, are marked congruent on the diagram. All right, let's try a proof here. So use the HL theorem. So here are some marks. I have two right triangles. I know SP and QR are congruent. These are hypotenuses. Well, look at this. I also can prove PR is congruent to itself, and that's going to be the leg. I can use HL here. So let's fill in the dots. Angle PRS and angle RPQ are right angles. We are given SP is congruent to QR, but we also know PR is congruent to RP by reflexivity. So these must be right triangles. So RPQ. Therefore, by HL, these two triangles must be congruent. Okay, problem number 2. All right, so we are given CD is congruent to EA. Those are hypotenuses. We are given AD is perpendicular bisector of CE. So if it's a perpendicular bisector, it's going to bisect these lines. And notice, right angles, I have a hypotenuse and I have a leg, we're going to be able to prove these things are congruent. So what do you know because AD is perpendicular bisector CE? I know that these angles are right. And I also know B is the midpoint of CE. So the congruent legs then are going to be CB and EB. The hypotenuse is going to be for triangles CBD, CD, and for EBA, EA. And I basically have laid out the proof for myself. So we are given that CD is congruent to EA. I know angle CBD and angle EBA are right angles by the definition of a perpendicular bisector. All right. So therefore, if they have right angles, I know these must be right triangles. Okay. And since this is also a bisector, I know line segment CB is congruent to line segment EB. So there we go. HL. Right angles, we have the hypotenuse and we have the legs. So triangle CBD is congruent to triangle EBA by the HL theorem. Okay. So a classmate says there is not enough information to determine whether the two triangles at the right are congruent. Is your classmate correct? All right, I have two right angles. I have the hypotenuses, and then by reflexivity, I can prove this. I have HL, these two are congruent. So there are three right angles. That's false. There are only two. There are two right angles. True. There are two congruent hypotenuses. True. There are no congruent legs. That is false. This is why the classmate was wrong. Two, you need the reflexivity property of congruence. True. And then LJ and LJ is going to be congruent. That's false because it wasn't given. We're going to use reflexivity. So do you always need three congruent corresponding parts to prove triangles congruent? No. You usually need three congruent parts, or congruent corresponding parts, let's be more specific. But not if the triangles are right triangles. So is my classmate correct? No. So since the hypotenuse and the shared leg of one right triangle are congruent to the hypotenuse and the shared leg of another right triangle, the triangles are congruent by the HL theorem. All right. And that's the end of this section.